Welcome back to my channel. Today we are tackling one of the most profound and fundamental concepts in calculus, the Fundamental Theorem of Calculus, both part 1 and part 2. This theorem bridges two seemingly separate ideas, that is differentiation and integration, into one elegant framework. Its importance cannot be overstated, and it is the backbone of much of modern mathematics, physics, and engineering. Let us break it down and see how it works. So for Fundamental Theorem of Calculus Part 1, it's basically used to differentiate integrals, right? So for instance, let's look at, we have to use Fundamental Theorem of Calculus Part 1 to differentiate this integral right here. So in that case, we have, so please follow this carefully. So we have dy dx equal to, now we have d dx, that is this part right here, right? And now our y was given as, because if we sub in y here, that is the integral. So we have a to x and t cubed plus 1 dt. So what the theorem says is that if this is a constant and this is a variable, which is either x, y, p, whatever, if it's just a simple variable like that, then all that you can do is to just replace this variable with what is over here. So in this case, we just replace t with x, so we have s cubed plus 1, and that is your answer for the differentiation. So remember, if we change this to say, if here is p and this is p and this is p, all that you get is just p cubed. I hope this is clear. Okay, let's look at a different one. So we have x 5, then 3t sine of t. We have to find dy dx. So in that case, we know our dy dx is equal to d dx of our integral from x to 5, 3t sine of t. We have the t here. So in this case, remember the theorem says that this part has to be a constant and this has to be a variable, but you see that it has been interchanged. So from our previous video, we know that we can interchange the upper and lower limits, and if we do interchange it, we should have a negative in front. So we have d dx. In that case, we have our constants coming down now, and our variable here, we have 3t sine t dt. So in that case, we have dy dx to be equal to, so negative right here, and since this is a constant and this is a variable, we can just go ahead to do our substitution. So wherever we see t, we put in x, so we have negative 3x sine of x, and that is your answer. I hope this is clear enough. Let's look at the third one. So we have y, then 1 to s squared cosine of t dt. So in this case, is this a constant? Yes, it is. Is this the variable that we want? No. Remember, we want a simple variable, a linear term, right? In this case, we have s squared. We don't want that. So whenever you have something that is not linear, we use the chain rule. So in that case, we have, remember, our chain rule is dy dx is equal to dy du multiplying du dx. So in this case, you are always going to make your u be equal to the term that is not linear. So in this case, we have x squared. So if you differentiate u with respect to x, you have 2x. So we can write our dy dx to be equal to, now we can have, this is our y, right? So we can have d du of our y is now 1, and x squared has been changed to u. So we have u here, cosine of t dt. Now we are multiplying by this right here. So we have multiplying by du dx, which was giving us 2x. So this is equal to, so now let's see, we have a constant and we have a linear term right here. So we can go ahead to do our substitution. So we have cosine of u, right? Okay, multiplying our 2x. So we have cosine, but u was giving us x squared. So we have x squared multiplying 2x. And this will just be your answer. So whenever you have a term that is non-linear, remember to always use the chain rule. Let's look at a different question. We have y equal to 1 plus 3x squared for 1 out of 2 plus e to the t dt. So in this case, remember to find the y dx, this is just d dx of your y, but your y is the integral of 1 plus 3x squared to 4 of 1 over 2 plus et dt. Note that we always want the constant to be down here, but now it's here, so we have to interchange it. And interchanging, we have a negative in front. We have now 4 here, then 1 plus 3x squared, and we have 1 over 2 plus et dt. So in this case, remember, since we do not have a linear term right here, what we have to do is to use the chain rule. So we have dy du multiplying du dx. In this case, your u is 1 plus 3x squared. So if you differentiate u with respect to x, if you differentiate 1, it goes to 0. And if you differentiate 3x squared, you have 6x right here. So doing your substitution, you have dy dx is equal to, now notice dy du basically means we have d du right here, right? So we have d du, and your y, which is this one, is now giving us this, right? So your y is just the integral of 4, then you have over here to be 1, so 1 plus, this is just u, then 1 over 2 plus e to the t dt. Remember, don't forget this negative right here, so you have to bring the negative here. Then you multiply by this du dx, and the u dx is what we had over here. So this is multiplying 6x. So now we can go ahead. Our dy dx is equal to negative. Now, since this is a constant and this is a linear term, you can just replace t with u. So just have 1 over 2 plus e to the u multiplying 6x. So this is just, if you multiply the numerators, you have just negative 6x out of 2 plus e to the u, but note that u is just 1 plus 3x squared. And this is your answer for the question. Okay. Let's move on. Let's look at a different question. So we have y equal to the integral of 0 to sine x of the t out of square root of 1 minus t squared. So in that case, we know that this is not a linear term we want, this is sine x. So what we have to do is to use the chain rule. So we have dy du multiplying du dx, but we know our u is going to be sine of x, and if we differentiate, du dx is just cosine of x. So in that case, we can have our dy dx to be equal to, no, this is a constant and this over here is sine of x, so we can approach, right? So then you can have d du, so d du of our y, but our y has been changed to this, right? Instead of sine s, we have u now. Then we have the t out of the square root of 1 minus t squared, then multiplying by the u dx, which is now cosine of x. So this is a constant, yes. This is a linear term we want, yes. So we can just replace t with u. So in that case, remember the t doesn't matter, so we just have 1 over here. So we just have 1 out of the square root of 1 minus. Now in place of t, we have u squared, then multiplying cosine of x. So this is cosine of x, because 1 times cosine of x is just cosine of x. In the denominator, we have 1 minus u squared, but we know that our u is sine, right? So we have sine squared of x, because sine squared will give you sine squared of x. But notice that we have some trig identities. Cos squared x plus sine squared x is equal to 1. So if you are to make cos squared as the subject, you are going to have 1 minus sine squared x. So it means what is inside the square root will simplify to cos squared x. And square root of cos squared x is just cos x. So if you divide these two, you have 1 to be your answer. So if you differentiate this with respect to x, you end up getting just 1. Okay, so I hope that really explains the part 1 concept. Now let's look at part 2. For the part 2, we've already done it in our previous video, just that we didn't notice it, right? So let's say we have been told to integrate from pi to 4 to 3 pi over 4 cosecant theta cotangent the theta. Okay, so the thing is, what do we have to differentiate to get cosecant cotangent? Remember, if you differentiate cosecant theta, you get negative cosecant theta cot theta. So we have positive now. So it means if we differentiate negative cosecant of theta, we should get positive cosecant theta cotangent theta. So it means that if we integrate this, we should get this right here. So we can have negative cosecant theta. The integral is 3 pi over 4, then pi over 4. Oh, this is clear. Okay, so this part over here is what we call the Fundamental Theorem of Calculus part 2. So basically it means you have to evaluate the upper limits first, then you subtract the lower limit from it. So that's the idea. So minus cosecant, now theta is 3 pi over 4, then minus, right, but we have a negative already, so it becomes positive, then cosecant pi over 4. So this is just the fundamental theorem of calculus part 2. So how do we evaluate this? From our previous videos, remember, cosecant is always 1 over sine. So in this case, you're going to have negative 1 over sine of 3 pi over 4, then plus 1 over sine of pi over 4. But what is sine 3 pi over 4? Now you can use the reference angles that we did at that time. So we have this is 0, this is 90, this is 180, this is 270, and cos and sine are always positive in the first quadrant. Cos is negative in the second, but sine is positive. They are all negative in the third quadrant. And over here, sine is negative, but cos is positive. Okay. And also we have reference angles. We have theta, we have pi minus theta. We also have theta minus pi over here as a reference angle. Then we have 2 pi minus theta right here. So why am I doing this? I'm doing this because over here, let's simplify. We want to find sine of 3 pi out of 4. And remember, 3 pi out of 4, where can we find it? 3 pi over 4 is somewhere here, right? Okay, so it is in our second quadrant. But to find it, this is the same as writing sine of, the reference angle that we are going to use is pi minus our theta, which is just 3 pi over 4. And this is just sine. Now, pi minus 3 pi over 4 is just pi over 4. What is sine of pi over 4? We know this already. Now, we can also use the triangle as we did before. I don't know if you remember this as well. So you can also remember this was 90, this was 45, and this was 45. So you can also use this as well, and this just simplifies to root 2 out of 2. Okay, so that one, it was 1, this was root 2, this was 1. So if you find sine of 45, sine is opposite over hypotenuse. So what is opposite of 45? It is 1. What is the hypotenuse? Is root 2. And 1 over root 2 is the same as root 2 over 2, as we have over here. So just note that. Okay, so now let's simplify. We have negative, we are back to this part. So negative 1 out of, now sine 3 pi over 4 is root 2 over 2 plus 1 over sine pi over 4. We've already established that it is root 2 over 2, so we have root 2 out of 2. So if we find the reciprocal of this just goes to just negative root 2 over here. We can also have the same thing right there. So clearly you can see that this and this are just opposite signs, right? So if we add them, this goes to 0. So if we integrate this, we have this. Let's look at our last example. Let's say you have the integral of pi over 6 to pi out of 2 of sine of 2x out of 2 sine of x dx. So in that case, remember, there's another property that says that sine of 2x, this is equal to 2 sine of x cosine of x. So in that case, we can rewrite everything. We can have pi 6 pi 2, then now 2 sine of x cosine of x dividing 2 sine of x dx. So we get to see that 2 sine of x will cancel 2 sine of x. So we just have the integral from pi over 6 to pi out of 2 of cosine of x dx. Now if we differentiate cosine, you end up getting positive sine of x, remember? And we have to evaluate from pi over 6 to pi over 2. So using the fundamental theorem of calculus part 2, we just have sine of the upper limit minus sine of the lower limit. And what is sine of 90? So pi over 2 is basically 90, which is what we have over here. So in that case, remember, over here we can have this coordinate. We can have 1, 0, we can have negative 1, comma 0, we can have 0, 1, and we can have 0, this is minus 1, and this is 0, 1. So the first value corresponds to cos, the second value corresponds to sine. The same thing over here, cos and sine. In that case, if you want sine of 90 is just 1. So sine pi over 2 is 1 minus, now sine of pi over 6 over here, we can use the reference triangle. So this is our 60 degrees, this is our 30, which is just pi over 6, and this is our 90. And we have 1, 2, and 3 from our previous video. So if you want sine of pi over 6, so sine is opposite of our hypotenuse. So this is pi over 6 right here. So what is the opposite of 30? We have 1 out of, what is the hypotenuse? That is 2. So in this case, we have 1 minus 1 half, which is just 1 half. So if we integrate this expression, this is what we end up getting. I hope this is clear. So that is the fundamental theorem of calculus part 1 and 2. I hope you now have a deeper understanding of how differentiation and integration are connected. If this video helped clarify the concept for you, please like, share, and subscribe for more calculus lessons. As always, leave your questions or future topic suggestions in the comments below. Thank you for watching, and I'll see you in the next video.